Earth is the planet that makes ordinary a magic trick. You wake up on it, breathe it, drink it, walk across it, and barely notice you're standing on a warm rock wrapped in air, sprinting around a star at 30 kilometers per second. From the ground, it feels personal and permanent. From space, it looks like a machine that knows exactly what it's doing. Blue water, white storms, brown and green continents, a thin protective haze, and it turns once every day like it's proud to show every angle. We haven't always understood where we live. For most of human history, the world meant the ground underfoot and a sky that seemed to revolve around us. Then the knots started to come loose. A Greek with a stick and a well, Eratosthenes, measured Earth's size by comparing shadows at noon. Sailors rounded capes that shouldn't have been roundable and quietly proved the horizon is a curve. Copernicus moved the sun to the center. Galileo's telescope showed Venus has phases, and Jupiter keeps its own moons, which only makes sense if Earth is one planet among many. Newton wrote gravity in math, turning "why does anything circle anything" into a solved problem. The headline isn't that we're small, it's that we're part of something, and that means we can ask how this particular world works. Start with the bones. Earth is about 12,742 kilometers across, and heavy enough that a bathroom scale feels like truth. It spins once every 24 hours, technically 23 hours and 56 minutes, relative to the stars, and loops the sun in about 365 and a quarter days, which is why calendars need leap days the way engines need oil. The axis is tilted by about 23.5 degrees. That tilt is not trivia, it's seasons. Lean a planet and different latitudes take turns under the spotlight. Spin sets the beat of weather. Tilt sets the rhythm of climate. The year sets a calendar. Everything alive can read without numbers. The air is where Earth's personality starts. Our atmosphere is mostly nitrogen and oxygen, with a pinch of argon, a whisper of carbon dioxide, and a wildly variable amount of water vapor. At sea level, pressure sits around 1 bar, enough to keep liquid water happy and your lungs on speaking terms with oxygen. That single bar does 4 big jobs. It moves heat so days don't cook and nights don't freeze. It filters radiation that would sandblast DNA. It makes weather, winds, clouds, rain, and weather, moves water and nutrients like a global delivery service, and it lets sound exist in air, which is why music, conversation, and yelling at your toaster all work. Compare the neighbors, and you see the sweet spot. Venus, almost our twin in size, wrapped itself in a 92-bar carbon dioxide coat and baked to 465 degrees Celsius. Mars, smaller and colder, lost most of its air and wears a thin CO2 scarf that can't hold heat or water for long. Earth landed in the middle, a breathable blanket, not too thin, not too thick, with water in all 3 phases and a set of thermostats, the carbon cycle, the water cycle, and plate tectonics that usually keep the engine from running away. Water is the superpower. About 71% of the surface is ocean, and oceans do far more than look pretty from orbit. They store heat, move it across the planet, dissolve gases, build storms, and host life from microbes to whales. The top few hundred meters are the noisy restaurant. Below that is the quiet library, cold, dark, and steady. Winds drive surface gyres. Temperature and salt drive the deep conveyor belt we call thermohaline circulation. That belt takes centuries to loop, but decides every winter which coasts get a gentle pat and which get slapped. On top of the ocean rides the water cycle: evaporation, condensation, clouds, rain and snow, rivers, groundwater, back to the sea. It's a heartbeat you can watch through a window, a thunderhead building in an hour, a river rising overnight, frost scribbling art on a windshield. No water cycle, no soil, no soil, no land plants, no land plants, no oxygen the way we like it. Pull one thread and the sweater goes with it. The land only seems solid. On human schedules, continents look nailed down. On Earth's schedule, they skate. The outer shell is broken into plates sliding over the mantle like crackers on thick stew. New crust rises along mid-ocean ridges. Old crust dives at subduction zones. Where plates spread, you get ridges and rift valleys. Where they collide, you get mountains. Where they grind past, you get earthquakes that remind everyone who's actually in charge. This conveyor is climate hardware. Subduction drags carbonates and organic muck down into the planet. Volcanoes belch some carbon back up. Weathering of fresh rock pulls CO2 out of the air. Slow, stubborn, indifferent, that's a thermostat you can count on over millions of years. Under the plates, Earth is layered like an onion forged in a blacksmith shop. The crust is a garnish, thin and brittle, everything we've touched. Beneath it, the mantle runs for thousands of kilometers, mostly solid rock that flows on long time scales. Deeper still, the outer core is a liquid metal ocean. Inside that, the inner core is solid iron, crystallized under pressure that would turn a lie into a diamond. The swirling outer core is the generator that builds Earth's magnetic field. That field is not a cute feature. It bends the solar wind around us and keeps charged particles from sandblasting the atmosphere the way they did to Mars. When storms from the sun slam into the field, the sky answers with auroras, charged particles spiraling down magnetic lines and lighting up atoms in greens, reds, and purples. If you've stood under a good one, you've felt space weather in your bones. Life doesn't just live here, it hacks the settings. Microbes ran the show for most of Earth's history and still handle jobs we're terrible at. Fixing nitrogen from the air into forms plants can use, chewing dead things back into the next meal, colonizing boiling springs and rock pores kilometers down. Plants bolted sunlight to chemistry. Chlorophyll grabbed photons, split water, and started spitting oxygen. At first, that oxygen rusted iron in the oceans and crust. Eventually, the sinks filled and oxygen spilled into the air, the great oxidation event. Oxygen is a chemical bully, but evolution knows what to do with bullies: hire them. Once oxygen was steady, metabolisms ran hotter and bigger, and multicellular life took off. Fast forward through 5 mass extinctions and a meteor that canceled most dinosaurs. Mammals were already waiting in the wings. Ice sheets pulsed. Hominins learned to nap stone, then to tell stories, then to move atoms with math. Now we build instruments that can weigh the planet, watch heat flow, and map rain from orbit, all while arguing about the weather as if it's personal. Climate, for the record, isn't a thermostat you flick. It's a system with parts that pull in different directions. Greenhouse gases trap heat. Clouds cool or warm depending on altitude and type. Ice reflects sunlight until it melts. Dark oceans absorb sunlight till they freeze. Volcanoes can mirror sunlight with aerosols for a year or load the air with carbon for a century. The planet's orbit wobbles and nods, tilt, eccentricity, precession, tuning ice ages and interglacials. Then comes the loud new input, us. We dig ancient carbon and toss it into the air in a geological heartbeat. We clear forests, change ground reflectivity, dam rivers, fertilize coasts. None of that turns Earth into a morality play. It turns it into a system with new boundary conditions. Systems respond. If you want a single clean picture to carry forward, use this. Earth is a stitched set of loops, water, carbon, rock, heat, air, life, nested inside each other and powered by sunlight and a hot core. Some loops are quick, like a thunderstorm. Some are slow, like mountain building. Some are wrecking balls slow, like burying carbon that will be dug up by apes with spreadsheets. The miracle isn't that it works. The miracle is that it keeps working while everything inside it changes. And the moon deserves its credit. It likely formed in a collision that splashed debris into orbit, then gathered into one big companion. That companion raises tides that stir coasts and estuaries. It steadies Earth's tilt so seasons don't go feral. It drags on our spin so the day lengthens very slowly, one borrowed second at a time. If you like poetry, a day is how long it takes Earth to tell the moon no, a little more than yesterday. That's the setup. A warm stone in the dark, wrapped in one bar of useful air, flooded with water, skinned with moving plates, lit by a star we orbit on a tilted axis, and escorted by a moon that steadies the ride. None of it is normal in the cosmic sense. All of it is normal to us, which is the sneakiest part. The better Earth works, the easier it is to forget the machine is there. Step into the air with me for a minute, because almost everything you feel on Earth starts there. The atmosphere isn't just a blanket. It's a heat engine wrapped around a wet rock. Sunlight pours in unevenly, too much at the equator, not enough at the poles, and warm air rises while cool air sinks. That simple imbalance builds the planet's conveyor belts, great looping cells that lift air near the tropics, drop it in the subtropics, and pass the baton to mid-latitude systems that carry storms toward the poles. If you could see it from space, without the clouds in the way, you'd watch whole rivers of air sliding east and west, bending around continents, climbing over mountains, then tumbling down the far side like spilled silk. The equator is where the drama begins. Sun-warmed air swells and climbs, pressure drops, water vapor condenses, and thunderstorms bloom in wide belts that migrate with the seasons. Sailors gave that zone a name that sounds like an insult, the doldrums, because the rising air kills surface winds and ships used to bake there. But higher up, it's anything but dull. That updraft feeds the planet's trade winds, steady easterlies that pushed caravels across the Atlantic and still shove cloud lines across satellite images like assembly lines. Farther poleward, the trades hand off to the westerlies, those storm factories that deliver cold fronts and chance of showers to anyone who lives in the temperate bands. Above it all run jet streams fast, narrow rivers of wind that form along temperature contrasts. They meander like drunk highways. When the jets kink and stall, the weather below them stalls too. And your week turns into a rerun. Rain again, heat again. That cloud parked over your house like it paid rent. Clouds are the visible handwriting of this machine. A cumulus is a hot breath that got somewhere. A thunderhead is that breath multiplied by 1,000, climbing until the air won't let it climb anymore, then spreading as an anvil because physics said so. High, thin cirrus are ice scribbles left by air that rose days ago and wandered across continents. Fog is just a low cloud caught taking a nap on the ground. You can read all of it once you know the alphabet. Warm air rising, moisture condensing, latent heat released. Repeat. Lightning is the spark between parts of a storm that's sorted charge by violently moving water and ice up and down again and again. Thunder is the pressure wave your ribs feel when that spark superheats a ribbon of air and it tries to expand faster than the air will allow. None of it is magic, but saying it out loud doesn't make it less impressive. When warm ocean water has room and time, it organizes into something even bigger, a tropical cyclone called hurricane or typhoon, depending on your longitude. These are heat engines with spiral arms. The sea feeds them. The outflow aloft vents them. The eye forms when the inflow is strong enough to clear a calm, bright hole through chaos. They don't follow your plans. They follow gradients, temperature, humidity, steering winds. Put enough heat in the water and the storms step up a weight class. Strip their fuel with cool water or dry air, and they fall apart like a story that forgot its point. Monsoons are the big breath in and out of continents. Land heats faster than ocean, so in summer, continents pull sticky ocean air inland, and it rises into drenching rain. In winter, the land cools faster. The pressure flips, and the winds pour seaward. If you live where the monsoon matters, the year isn't 4 seasons, it's 2, waiting and not waiting. The same physics runs at different scales. A sea breeze is a micro-monsoon that resets every day. Ocean cool, land warm, wind onshore by afternoon, off to bed at night. Now drop into the water itself, because the ocean is the atmosphere's big partner, and sometimes its boss. The top few hundred meters are stirred by wind and waves. Sunlight warms the surface. Storms pick fights with the upper layers and draw lines of white where the fight was. Below the mixed layer, the ocean stratifies into sheets of temperature and salt. Cold, salty water is heavy and sinks. Warm, fresh water is light and floats. That density trick runs the deep conveyor belt of thermohaline circulation, a loop so slow it seems like myth until you look at the chemistry of the water and see where it's been. In the North Atlantic, for example, surface water cools, grows saltier as ice forms, and leaves the brine behind and sinks into the abyss to start a 1,000-year trip. Elsewhere, cold, nutrient-rich water upwells along coasts and feeds plankton blooms that feed everything else. You can draw the food web all you want. It still starts with physics and light. Currents tie coastlines together in ways postcards never will. The Gulf Stream is a highway of heat that keeps Western Europe's climate softer than its latitude deserves. The Kuroshio plays a similar game in the Pacific. Gyres swirl in each basin, hoarding floating debris in slow, cruel spirals. Storm tracks follow where temperature contrasts are sharp. Sea ice grows, reflects sunlight, and thickens the contrast, then breaks and drifts and melts, and the contrast fades. The Arctic, an ocean with continent walls, grows and loses a skin of ice that moves with the wind. The Antarctic, a continent with an ocean moat, throws a circumpolar current around its waist like a belt. And that current keeps southern ocean waters on their side of the line unless something pries them across. Every few years, the Pacific flips a coin named El Niño La Nina, and the planet's weather shuffles. During El Nino, warm water sloshes eastward, trade winds slacken, the usual upwelling off South America weakens, and global patterns tilt. Rains fall where they usually don't. Fires bloom where they usually don't. Hurricane basins either wake or nap out of turn. During La Nina, the trades pull tight. The warm pool piles toward the west, upwelling strengthens, and the patterns tilt the other way. If you want to watch a planet breathe on a 2 to 7 year rhythm, that's your metronome. Back on land, the rock itself is busy in slow motion. Mountain ranges aren't just scenery, they are climate gear. Lift air, and it cools. Cool air can't hold as much water, so it drops it. That's how you build lush windward slopes and rain shadows that look like someone forgot to order clouds. Dust lofted from deserts fertilizes ocean plankton and rainforest canopies half a world away. Rivers trap sediment behind dams, starving deltas that used to grow fingers into the sea. Coastlines migrate because sea level moves, and sea level moves because ice sheets gain and lose mass, and because warm water simply takes up more space than cold water. Tide gauges along harbors quietly keep score while we invent reasons not to read them. The magnetic field hums through all of this like a note you don't hear until you turn off the radio. In calm times, it just works. Cosmic rays deflected, satellites happier, compasses boring in the best way. In storm times, the field takes the hit and the upper atmosphere lights up. That shield has reversed many times, north and south, swapping labels like a prank, but it never turns off completely. Lava cools and locks in the direction of the field it felt. Ocean crust spreads and freezes stripes of magnetization that mirror across ridges. A ship with a magnetometer can read those stripes like barcodes and tell you where the plates have been. A geologist with a hammer can read the lava's memory and tell you where a continent sat when that rock was soft. Life answers back to everything I've just said. Forests plant their own weather by sweating water into the air and seeding clouds. Prairie grasses fix carbon deep in soil, building dark richness that can survive fire and drought better than leaves alone. Coral reefs raise wave breakers out of chemistry and sunlight. They tame coasts as long as the water stays within the narrow window that reefs like. Beavers stitch wetlands with sticks and patience. Those wetlands slow floods and filter water like green kidneys. This is the part where environment stops being a poster and starts being the hardware store sign that says closed for inventory until spring. The planet works because systems talk to each other. We talk back too, usually louder than we think. Agriculture replaces wild root work with neat rows that shed water faster. Cities wrap soil in asphalt and concrete and build hot islands that make their own tiny weather. Smokestacks and tailpipes add invisible gases that are invisible right up until they aren't. The signal is not a secret. Thermometers told us first, glaciers told us next. Oceans are telling us now as they swell, nudge shorelines inland, and take bites out of beaches during storms that used to only nibble. You do not need to hate humanity to read a thermometer. You just need to be awake. And yet for all the warning lights we've learned to recognize, the planet's generosity is the louder story if you let it be. Watch a cold front sweep in. Wind shifts, pressure falls. That line of bruised clouds gallops over your house, the temperature drops 10 degrees in 10 minutes, and the air turns new. Stand under a clear night sky in the desert and realize the stars you forgot are still there and still rude about it. Walk a beach at low tide and see an intertidal city laid bare. Anemones clamped shut like fists. Snails writing crooked proofs in thin water. Shorebirds running the same routes they ran last night. None of it needs you to be meaningful. All of it regards you as weather. So yes, Earth is a machine with parts and loops and math you can write down, but it's also the set of ordinary miracles that those parts allow. Rain that smells like a promise, fog that edits a city into a drawing, frost-etching glass and ferns that would impress a botanist, thunder turning an afternoon into a drum solo, rivers braiding and unbraiding till they reach a level the planet likes. If you've ever felt the whole thing click into place for a second, standing in wind that smells like snow, watching the first leaf rot into soil, feeling your lungs wake up after rain, you met the machine without a tour guide. That's the trick of living here. The more you learn how it works, the more obvious it becomes that ordinary is just the word we use for miracles we've gotten used to. Walk down from the clouds and put your hand on the ground. Rock looks permanent because you haven't watched it long enough. Give it time and it behaves like bread dough and glass and teeth, hard until it isn't. The crust is a quilt of plates, and those plates move because the mantle underneath is warm enough to creep. Not fast. Your fingernails grow quicker, but relentless. Where plates pull apart, the planet unzips and makes new seafloor. Where plates collide, something has to give. Ocean crust usually dives, continents crumple, mountains rise like slow fists. You can stand on a ridgeline and feel the push in your calves. That's not landscape. That's stress being relieved. Volcanoes are the pressure valves. Some are tidy, building wide, friendly shields from runny lava that oozes and stacks into islands. Others are drama queens, thick and gassy, storing pressure until physics yanks the pin. Then ash builds a sky where the sky used to be, and daylight goes weird. People tell stories about angry gods when a mountain coughs. The real story is simpler. Rock melts, gas comes out of solution, and the planet vents. Sometimes that vent feeds the soil for generations. Sometimes it interrupts a year of summer and gets written into tree rings because sulfur aerosols bounced sunlight back to space. Earth doesn't ask if we're ready. It sends the memo as ash. If you want to read the planet's diary, pick up a rock and treat it like a page. Sedimentary layers are sentences written by water and wind, stacked neatly when the story is calm, ripped and cross-bedded when the current changed its mind. Fossils are footnotes that say, "This was here. The sea used to be over your head." A fern once called this home. Igneous rocks are the exclamation points, cooled from melt and crystal by crystal, telling you how fast they chilled and what they were made from. Metamorphic rocks are the edits, old words rewritten under pressure and heat, until the original ink shows through only in hints. Geology is not dead history. It's a living language. The grammar just runs on a scale that ignores our patience. Ice writes in capital letters. A glacier is a river that forgot how to hurry. Snow piles, compacts, turns to ice, and starts to flow under its own weight. It doesn't care if there's a forest in the way. It grinds mountains into flour and drags boulders like souvenirs. When it finally retreats, it leaves land stitched with moraines, pocked with kettle lakes, striped with striations that all point the same way. You can stand in a valley and see the height of the ice in the line of polished rock halfway up the wall, proof that winter once owned the place. Sea ice is lighter work, a seasonal skin that grows and shrinks, but even that skin matters. White reflects sunlight and cools the neighborhood. Dark water drinks sunlight and warms. Shift the balance, and the system answers everywhere, not just at the pole. Rivers are patient thieves. Give a stream a slope and time, and it will carve a canyon, carry mountains as silt, and build a delta that sticks its tongue into the sea. Every bend is a negotiation between velocity and friction. Every floodplain is a contract signed in mud. We build towns on the fat part of that signature because flat ground near water is convenient. Then we act surprised when the river does river things. Dams pause the story, storing water in graves of sediment behind concrete, but even a stopped sentence has to end. Sediment starves the delta, and the coast, deprived of new land, lets the sea have what it wants back. Coasts are the planet's chalk line between two moods. Waves eat headlands and feed beaches. Storms rearrange property lines and then leave you arguing with your insurance agent about the meaning of 100-year event. Tides draw calendars in mud and sand, opening doors twice a day for creatures that have their own clocks. Salt marshes build themselves one blade at a time. Mangroves net coastlines together with roots that look like architecture. Coral reefs, if the water stays in their comfort zone, raise breakwaters from pure chemistry and sunlight. Take the water too warm or too acidic, and the reef flips from bright city to ruined library in a season. The ocean will keep being an ocean. The question is, what version of coast we get? Step back from the map and look at the magnet in Earth's chest again, because it's doing quiet work every day. The field is not a static dome. It's a windswept cape. Space weather pulls it into a tail, pinches it, snaps it, and the whole thing rings. Satellites feel the punch. Power grids feel it too, in currents that were never invited. When the field is strong and tidy, auroras stay near the poles like polite house guests. When it's agitated, the curtains wander south, and people who never asked for physics suddenly have their breath taken away in green. Lavas remember all of this. They cool with iron-bearing minerals aligned to the field like tiny compass needles. Stack enough lava flows, and you get a barcode of flips and pauses. Drag a magnetometer across the seafloor, and you can see those stripes mirrored across mid-ocean ridges. Proof that new crust is made there and shoved aside. That's not theory. That's literally recorded on the planet like tape. Life climbs into every gap the physics leaves. Lichens colonize bare rock and start the long hustle toward soil. Grasses stitch wind into prairie and lock carbon away where fire can't find it easily. Forests pull rain out of passing air by sweating water through leaves. The forest makes its own weather, like a well-hydrated conspiracy. In the ocean, plankton turns sunlight and nutrients into bloom after bloom. Their shells snow down as marine confetti that will harden into chalk and limestone. A cliff of white rock far from the sea is not a mystery. It is a time machine, a former ocean floor lifted into sunlight by plates that don't ask for permission. You can rub it between your fingers and feel the ghosts of things too small to see. If this sounds like the planet is busy, good, it is. But it's also precise. Systems talk to each other with feedbacks that are not negotiable. Warm the air and it can hold more water vapor. More water vapor is a greenhouse gas. That can warm the air again. Add enough heat to the ocean and hurricanes find their teeth. Take the heat away and they mumble. Strip a slope of roots and the first hard rain will show you gravity's sense of humor. Build a city and you raise a heat island, a little weather system with its own afternoon thunderstorm rules and morning fog habits. None of this is politics. It's cause and effect with a sense of timing. Human time is the rude guest at this long party. We move rocks faster than rivers in some places. We rearrange nitrogen chemistry with fertilizer more than lightning does in a year. We add ancient carbon to modern air in volumes that can be measured with the same bored thermometers your grandparents used. The ocean swallows a third of it. The land tries to help, and the rest piles up where infrared light would like to escape. The result isn't a mystery if you read the gauges. Heat goes up. Ice retreats. The date of the first frost wanders. The map of where mosquitoes feel at home redraws itself without asking you first. Natural isn't a moral category, it's a speed limit. We're doing 70 in a school zone and arguing about whether the sign applies to us. And still, most days, Earth gives you joy for free if you lift your eyes. A morning when the air is so clear, you can see the sharp line where a cold front wiped the slate clean. A night in late summer, when the Perseids write brief notes across the sky, and you find yourself laughing at rocks that decided to burn for you. The way a creek sounds different after a day of rain, throatier, confident, because it temporarily remembers being a river. The way petrichor smells the same every century because the chemistry that makes it hasn't changed. None of that is small. That's the machine telling you, in every sense it has, that it is working. If there's a rule that carries through all of this, it's simple enough to say without a chart. Energy flows, matter cycles, and time enforces. Sunlight pours in, low-grade heat leaks out, and everything in between is choreography, water, carbon, nitrogen, phosphorus, round and round that go through air, soil, rock, and bodies. And the clock never stops. The calendar of storms, the metronome of tides, the geological patience of plates, these are not decorations. They are the instructions. Learn the rhythm, and suddenly you're not surprised by the beat. Ignore it, and Earth will keep playing while you stumble. Take one last walk, this time at dusk. The air cools and sinks. A land breeze finds your face as the sea holds the day's heat a little longer. Above you, high cirrus catch the last light and glow pink, because ice is good at being dramatic. Somewhere north, the jet stream is already drafting tomorrow's headlines. Somewhere south, a thunderstorm collapses into rain and relief. Under your feet, plates grind a millimeter, groundwater threads through pores, roots trade sugars for minerals with fungi older than your language. None of it is waiting for your approval. All of it is the reason you get to stand there and call this place home. Head into the living layer, the skin of Earth where rock, water, air, and sunlight sign a lease and life moves in. It isn't one thing. It's a patchwork quilt, stitched with every trick evolution ever learned. Deserts look empty until dawn, when the whole place gets busy before the heat arrives. Lizards writing cursive in dust. Beetles harvesting fog off their backs. Plants hoarding water in bodies that look like jokes until you try to live there. Rainforests sound like someone forgot to turn off the planet. Layers of leaves, insects making electricity with their wings, vines throwing ropes from tree to tree because sunlight is currency and everybody is broke. Grasslands are the quiet professionals. Roots deeper than your arm, soil as black as a thunderhead, a wind orchestra that never rehearses and still shows up in tune. Tundra keeps time in slow motion, mosses and the dwarf shrubs, permafrost thinking about thawing, caribou drawing maps with their hooves that wolves rid like gossip. Mountains are climate machines stacked vertically. Bottom feels like June, tree line feels like October, summits feel like Mars. Coasts are deals with the devil, food everywhere, storms on retainer. All of it runs on partnerships. A flower is a brightly colored advertisement for a bee's transportation business. A tree root is a contractor. The real project manager is the fungus netted around it, swapping sugar for minerals through filaments so thin they make hair feel clumsy. Coral is an animal with roommates, algae paying rent and photosynthesis until the water gets too hot or too acidic and the lease collapses. Termites farm fungus, ants farm aphids. People farm everything and call it a grocery store. The point isn't cleverness, it's network. The planet works because energy is passed cleanly and waste doesn't stay waste for long. Leaves fall, microbes throw a party, and next spring the party becomes soil. You can hear the logic. Nothing is trash. Everything is future. Fire belongs here too. In some places, flame is not a disaster, it's a schedule. Lightning sets a prairie on a controlled rant, and grasses shrug it off with buds sleeping underground. Pine forests drop cones that only open when heated, because fire is their midwife. We decided for a century that fire should never happen, and then acted surprised when a century's worth of fuel turned a spark into a freight train. The lesson is not mystical. Systems that evolved with fire need fire, which is a very earth way of saying, don't pull the battery out of the smoke alarm and pretend the stove won't burn the roast. The sky has tricks that barely look real. Above thunderstorms, red sprites and blue jets flicker where you thought nothing existed, electrical ghosts dancing between cloud tops and space. High above, noctilucent clouds glow like silver fences because ice crystals are catching sunlight when the ground is already dark. On cold, calm nights, halos circle the moon because tiny, flat ice plates in the air are all tilting the same way and bending light like a million polite prisms. There's a whole meteorology of strangeness up there, and almost all of it comes down to the simplest rule we have. Water changes phase, light bends, electricity looks for a path, and the atmosphere says yes. Zoom up to the line where pilots stop arguing and call it space. The Kármán line is an imaginary handshake around the planet where air is too thin to support an airplane's wings the old-fashioned way. Above that, satellites stitch a nervous system around Earth. Some watch clouds, some weigh the shape of the sea. Some listen for the faint hiss of charged particles. Some just tell your phone where you are when you pretend not to be lost. Look down from one of those orbits at night, and you'll see city lights as a species-level confession. This is where we live, and this is how we forget to turn things off. The same eyes see fires, ships carving lanes through darkness, fishing fleets lit like stadiums, volcanoes testing the smoke alarm, auroras writing poetry we don't deserve. Cities are ecosystems that refuse to admit it. They grow like coral reefs with scaffolding and coffee. Pavement redirects rivers into storm drains and heat into the air. Roofs collect sunlight and either waste it as glare or harvest it as power, depending on whether we bothered to think ahead. Pigeons reinvent themselves as urban doves. Coyotes commute at night like shift workers. Hawks learn the subway schedule from the shade of a billboard. Street trees write quiet biographies in their rings of droughts and construction years. Human-made edges breed their own weather, a bubble of warmth, a tendency for afternoon showers, a fog habit at sunrise. You can hate cities and still admire their physics. The laws don't care about your aesthetic. Agriculture is civilization's signature and the planet's negotiation with us. We turned wild grass into dozens of kinds of cereal and called that progress because we like being fed every day. In exchange, we asked soil to be immortal. It isn't. It's a living community easily bullied into exhaustion by plows and chemicals if we forget that roots and microbes do the heavy lifting. When fields keep a skin of plants, when hedgerows connect habitat like handrails, when water sinks into ground instead of sprinting off with the first hard rain, the land answers back with resilience. When we pretend the rules don't apply, the bill arrives in dust and flood. Rivers and dams got their own messy divorce. Dams keep lights on and fields watered, and they also trap sediment that deltas need to stay alive. Take the silt out of the equation, and the sea will quietly move the shoreline to where physics wants it. That's not a policy debate. That's a balance sheet. Somewhere downstream, oysters used to be cheap, and the marsh kept storms from walking into town. Without sediment, and with a little extra sea level, the oysters get expensive and the storms stop knocking. If you want a sense of how fast natural can flip, remember that Earth has always edited itself with abrupt events. A fault sticks, stress builds, and one afternoon, a valley shifts a meter sideways in 20 seconds. A volcano plugs, pressure climbs, a cap fails, and a column of rock powder and gas climbs into the stratosphere like a god changing the channel. A meteor minding its own business gets its orbit nudged and finds itself multiplying gravity by speed into a day nobody forgets. The rock doesn't care that calendars exist. Earth does calm, and it does sudden. You live between those two tempos. Respect both. There's also the quiet danger of success. We got very good at not dying young, and then we did the math on energy and decided to spend sunlight from 100 million years ago all at once. It worked brilliantly for a while. Lights, hospitals, cold chains that keep food safe. Then the receipt arrived. Extra heat in the air, extra acid in the sea, ice that knows arithmetic, forests stressed until they swap from helping us to asking for help. None of this means doom by default. It means homework. The same species that learned the shape of Earth with a stick and a well can figure out how to live on it without breaking the thermostat. The trick is to stop arguing with the instructions printed into physics. If you're still looking for the miracle under all the machinery, take a walk and let the planet show you the lesson plan. A puddle skinning over after sunset, then flashing to liquid when a breeze slides by. A hawk working a thermal spiral you can't see until a leaf rides it too. A canyon wall that tells you a story in layers you can read with your fingers. Sandstone beach day, siltstone, quiet lagoon, volcanic ash Tuesday. A spring morning that smells green before anything is actually green. These are not metaphors for Earth. They are Earth. This is the part where the script doesn't need adjectives, because the place does the speaking. And on the days when Earth feels too big to get your arms around, shrink it back to something you can hold. Find Polaris and learn one star's stubborn refusal to move. Watch the sun set a little farther south each evening as winter approaches, and realize your tilt is picking a new page on the calendar without asking your opinion. Catch dew on grass and think about the invisible parade of water molecules walking a circuit older than continents. Stand in surf and feel the moon tug at everything, including you, and understand that tides aren't out there. They are here, in your knees. It's all the same lesson, repeated in different accents. Energy in, heat out, matter cycling, time enforcing, feedbacks keeping score. Earth doesn't require worship. It requires attention. It rewards that with competence and occasional joy. And the more you pay attention, the more the rules start to feel like kindness. Here is how rivers behave. Here is how soil stays alive. Here is how to build where wind will not shovel your roof into the neighbor's yard. Here is when lightning prefers to say hello. We are not guests, and we are not landlords. We are tenants with a lease written in water and rock, signed in light. Read it. Live by it. The planet is already doing its part. Earth doesn't need us to be impressed. It will keep turning, trading day for night, swapping seasons with a tilt, moving water and rock and carbon in loops whether anyone claps. But knowing the choreography changes how you stand in it. You stop treating blue sky as wallpaper and start seeing a working heat engine. You stop calling mountains scenery and start hearing plates arguing in slow motion. You stop thinking rain is just wet and start recognizing a planet delivering freight. We live on a rock with a metal heart and a moving skin, wrapped in one bar of useful air, soaked in salt water, steered by a moon that steadies our tilt, and shielded by a magnetic field spun from liquid iron. That setup is not guaranteed anywhere. It's the weird, lucky outcome of heat, gravity, chemistry, and time doing their thing long before we showed up. Life climbed on top of that hardware and rewired it. Microbes fixing nitrogen, forests sweating clouds, reefs raising breakwaters out of light, until the surface became a negotiation that never ends. The rules aren't mystical. Energy flows, matter cycles, feedbacks keep score, and time enforces. We've gotten good at turning those rules into comforts. Lights on, fridges cold, cities humming. We also got cocky and started spending ancient sunlight like it was pocket change. The gauges noticed. Extra heat, shifting storms, retreating ice, seas pushing up the beach. None of it cares about our politics. That's not doom by default. It's a reminder that competence beats denial. The instructions are printed in physics and geology: where to build, what to leave alone, how to keep soil alive, how to stop arguing with rivers, how to let forests be forests so they'll keep making rain. Read the manual. It's etched into the place itself. So end with something simple. Step outside at dusk. Feel the land breeze slide off warm ground toward a cooler sea. Watch high ice clouds steal the day's last color. Somewhere above, the jet stream is writing tomorrow. Somewhere below, roots are swapping sugar for minerals with fungi older than our stories. Over the horizon, the moon is tugging a whole ocean a few inches uphill. This is not background. This is the main act. call it ordinary if you want. That just means you've been lucky enough to live inside a miracle long enough to get used to it. Treat it like home. Act like a decent tenant. The lease is written in water and rock and light, and we're already signing it with every breath. Before we wrap, here are a handful of things about this planet that are almost unfairly cool. Earth is the densest planet in the solar system, not the biggest. That's Jupiter, but pound for pound, we pack the most mass into the least space. That dense interior includes a liquid outer core of iron alloy that spins up our magnetic field. The field is why compasses behave, why auroras happen, and why the solar wind doesn't sandblast our air the way it did to poor Mars. We're also the only world we know with long-lived liquid water at the surface, not just puddles, oceans, rivers, rain, snow, ice, the whole cycle. That cycle is a thermostat. Evaporation cools, clouds reflect, rain moves heat and nutrients. You can literally smell the system at work. Petrichor, that sweet mineral scent after first rain, is plant oils and airborne compounds shaken loose when dry ground meets wet. Every breath you take is a remix. The oxygen mostly comes from photosynthesis, on land, yes, but also from ocean plankton doing quiet work at shocking scale. The nitrogen is borrowed from bacteria that crack the triple bond in the air and hand it to plants. The carbon, at least some of it, has been in and out of rocks, shells, and trees more times than you've rebooted your phone. If you want to get poetic about it, atoms from ancient forests and long-gone animals are touring your lungs right now and will be busy somewhere else by next week. Days are not actually 24 hours long. A sidereal day, measured against the stars, is about 4 minutes shorter, and tides are slowly stealing spin from the planet. The result? Earth's day lengthens by a couple of milliseconds per century. Meanwhile, the moon, paid in angular momentum for all that tugging, is drifting away at a few centimeters a year. That's slow on human time and fast on planetary time. If you want to feel it, you won't. But if you want to measure it, lasers bounced off retroreflectors on the moon have been tracking the drift for decades. Gravity isn't perfectly even. Earth is slightly squashed, wider at the equator than pole to pole, so you weigh a touch less at the equator than in, say, Iceland. That bulge also means the point on Earth farthest from the planet's center isn't Everest. It's Mount Chimborazo in Ecuador, which gets a head start by sitting on the equatorial bulge. Everest is taller above sea level. Chimborazo wins the closest to space prize. Both, for the record, are beaten by a Hawaiian volcano if you measure base to summit. Mauna Kea rises more than 10 kilometers from sea floor to peak. The longest mountain range on Earth isn't on any map you've hung on a classroom wall. It's the mid-ocean ridge, a stitched-together volcanic seam that snakes around the planet for more than 60,000 kilometers. New crust is born there. Old crust dives back into the mantle at subduction zones. That slow conveyor belt is how carbon gets buried and belched, how continents wander, and why mountain ranges keep showing up where plates can't agree on whose turn it is to move. Deep beats high, too. The Challenger, deep in the Mariana Trench, scrapes almost 11 kilometers below sea level. If you could drop Everest into it, there'd still be water over the summit. The pressure down there would crush a submarine like a can. unless it's specially built not to be crushed. Up here we fuss about weather. Down there the ocean is a world unto itself, dark, cold, and full of creatures that look like evolution. Tried all the sliders just to see what would happen. Our air looks simple, blue dome, white clouds, but the mix is sneaky. Roughly 4/5 nitrogen, about a fifth oxygen, then a sliver of argon, a little carbon dioxide, and water vapor that changes by the minute. That tiny slice of CO2, now over 400 parts per million, is small by percentage and huge by effect. It traps heat and tips the balance. Water vapor does the same, but it's a response, not a trigger. Warm the air with something like CO2, and the air holds more water, which warms it more, and you've got a feedback loop. This is why a little in climate chemistry never means nothing. Lightning is Earth's signature party trick. A good thunderstorm sorts electric charges by throwing water and ice up and down fast enough to make a battery angry. The spark that follows heats a channel of air hotter than the surface of the sun for a blink, and the boom you feel in your ribs is the air trying to expand faster than physics allows. Up above the storm, where you think nothing happens, red sprites and blue jets flicker, electrical ghosts connecting the cloud tops to the edge of space. Tides are simpler than they look and stranger than they sound. The moon pulls hardest on the ocean under it and least on the ocean farthest away. So you get two bulges racing around the globe while Earth spins. The sun's gravity weighs in too, boosting tides when sun, moon, and Earth line up, softening them when they're at right angles. In shallow seas and long bays, the water sloshes like wine in a tilted glass, and local geography turns a global rhythm into a dozen regional accents. Auroras are the solar wind made visible. Charged particles ride Earth's magnetic field lines down toward the poles and smack into atoms high in the atmosphere. Oxygen glows green and red. Nitrogen throws purple and blue. The result is a curtain of light you can't describe without sounding like you're exaggerating. There's one in the north and one in the south. They're fraternal twins. Animals rid the planet better than we do. Birds migrate along invisible highways of wind and magnetism. Sea turtles steer partly by the angle of starlight and partly by cues we still haven't pinned down. Salmon smell their way home. Monarch butterflies cross a continent using a clock in their antennae, talking to a compass in their eyes. To a wildebeest, the Serengeti is a calendar you can eat. We invented GPS. Everything else invented not getting lost the hard way. The Sahara hasn't always been a desert. Over the last few 100,000 years, it has flipped between green and dry as Earth's orbit slowly shifted and the monsoon moved north and south. Rivers that look like scars on satellite images once ran. Hippos lived where sand now rules. Earth is not static. It's a house that keeps rearranging the furniture. Most of the oxygen you're breathing right now was made by things you'll never see. Marine phytoplankton, microscopic plants, punch far above their weight. They bloom where nutrients and sunlight meet, photosynthesize like tiny maniacs, and snow down as calcium carbonate and organic matter when they die. Some of that ends up as chalk and limestone. A white cliff far from the sea is just an ancient ocean floor lifted into light. Coasts are deals we keep renegotiating. Sand is loaned by rivers and stolen by waves. Storms redraw property lines and don't care about your paperwork. Salt marshes and mangroves build land one blade and one root at a time, breaking waves and holding mud if we let them. Coral reefs raise breakwaters out of sunshine and patience until water gets too warm or too acidic. And then the city goes silent. The ocean keeps being the ocean. The question is which version of coast we get to live with. Here's one to keep in your pocket. The color of the sky is a physics lesson hiding in plain sight. Air molecules scatter short wavelengths of light more efficiently than long ones. Blue spills everywhere, while reds and oranges pass through. When the sun drops, its light takes a longer path through the air, the blue scatters out, and the leftovers paint the horizon. A pretty sunset is a math problem with excellent branding. And finally, a small humbling metric. If you compress Earth's history into a single year, the planet forms on January 1st. Life shows up by March. Oxygen begins to matter in late summer. Multicellular life gets bold in November. Dinosaurs dominate around Christmas. They're gone by December 30th in the evening. All of human history, the caves, the ships, the telescopes, your phone, fits into the last minutes of December 31st. That doesn't make us small in a sad way. It makes this moment obvious. We are loud, brief, and lucky, standing on a world that does miracles as a matter of routine. Use as many of these as you like to close the piece. They're sticky in the ear, easy to picture, and honest about the rules. Earth doesn't need hype. It just needs a little attention.